Hello. I wanted to make a separate video for the end of example 1 with z-scores because this can be a little challenging for students. So notice I put a line here and I have stars. These are the ones that seem to be a little challenging because they're kind of backwards from the ones we just did with the z-scores less than, more than, and in between. And here's why. So what height has 40% of the observations falling below it? Well, these are different than the previous examples that gave me the height and asked for the percent. Gave the height, asked for the percent, gave the height, asked for the percent. So in this case, we're given the percent below, but they don't give us the height. So this is kind of a backwards problem. We're still going to work through it in kind of the similar strategies. So here's our formula. Z equals x minus mu over the standard deviation. Well, I know that the average is 64 still. I know that the standard deviation is still 2.5. We don't know what x is. That's what's different about this problem. Normally we're given x. And I don't know what z is, but they gave us a clue. And the clue is 40% below. 40% below. Now, please understand, 40% is not the z. 40% is not the z. Remember, z is a number that we look up to find the percent. So we're going to use a picture. So 40% below would be the bottom 40%. Now again, it could probably be about here to be a little bit more accurate, but the idea is that it's the bottom 40%. So our goal is to find 40% below gives us what z, and we'll use some algebra to find x. So let's agree that 40% is 0.40 and we're looking for below. Well, if we're on this side, that means our z-score must be negative. Our z-score must be negative, and we're looking for 40% below. So we're going to go to the negative z table and look for 40%. Remember, it's below, less than. So we'll go back to our negative z because we know it's on the left side. Couldn't find 40 here if we wanted to. So we're going to look for the closest to 0.40 in the percents. Not 0.004, not 0.04. We're looking for 0.40. And the closest to 0.40, would be between these two. Now, either one is okay. Either one is okay. Technically, this one's a little closer, but either one would work. It's just going to be off by a little bit. And we want to find out what z-score gives us that. It'd be negative 0.25. Negative 0.25. So that was backwards. We're given the percent and ask for the z-score rather than giving the z-score and ask for the percent. So that's the tricky part. So 0.4013 is pretty close to 0.40. The z-score that matches with that is 0.25. Okay, so that's the tricky part of that problem. So we go back. We now found our z-score is negative 0.25. We plug it in for z. We have everything filled in except for x. A little bit of algebra, you're going to have to remember that. To get rid of divided by 2.5, we multiply by 2.5. That turns to 1. If I multiply this side by 2.5, I got to multiply the other side by 2.5. So 2.5 times negative 0.25 is negative 0.625. Now I have x minus 64. To isolate the x, to get rid of minus 64, we add 64, which gives 0. If I add 64 to this side, I add 64 to this side. So negative 0.625 plus 64 gives us the height of 63.375 inches. So the height that has 40% of the observations falling below it would be 63.375 inches. So if you are 63.375 inches, 40% of women are shorter than you. Okay, and again, a little backwards, but let's try another one. Now it says, what height has 20% of the observations falling above it? 20% above this time. So we still don't know our z, don't know our x, but the average is still 64, standard deviation is still 2.5. So we're going to use that 20% above now, 20% above, to find the z so we can solve for x. So we go to our picture. 20% above would be here, 20% above would be on the top end, but we have a little issue. First of all, if it's 20% above, our z-score has to be positive because we're on the right side of the 0. And also, the table never tells us above. The table never tells us above. The table always tells us below. So we have to think a little bit. If it's 20% above, and the table doesn't tell us above, but it tells us below, if it's 20% above, therefore, it must be 80% below. So to be in the terms of the table, we needed less than, not more than. So if it's 20% more than, above, it must be 80% below. 80% below. So we're not going to be looking for 20.20, we're going to be looking for 80.80 in the percents. Now that's a little tricky, but if we can agree that it has to be positive, when I go to the positive z table, you'll never find 0.20 because the table doesn't tell you above, it only tells you below. So the closest to 0.80 would be this one right here, and the z-score that matches with that is 0.84. Now please keep in mind, another reason why I chose these numbers, this represents 80% less than, which is 20% above. 0.84 is the z-score, not a percent, 0.84. Even though they're close to each other, they're two very different things. So once you find the z-score is 0.84, you put it in for z. We have everything except for x, so I multiply both sides by 2.5, which leaves us with 2.1 equals x minus 64. Add 64 to both sides, we get 66.1 inches. So the height that has 20% of the observations falling above it is 66.1 inches. So if you are 66.1 inches, 5'6.1", 5'6", let's say, then 20% of women are taller than you and 80% of women are shorter than you. Okay, we're going to do another example in the next video.